did everybody understand the polymorphism, virtual inheritance, about the virtual functions and abstracts, interface concepts? Okay, looks like everybody completed, so I am assuming that everybody has understood about the virtual functions. So from the object-oriented programming perspective, I think I have mostly covered whatever I wanted to cover. There are a few things, some concepts in C++ that I would like to cover, which is also important, which would also kind of help you, just like object-oriented programming. So one of the things is templates. So let's learn what are templates. So say I have a function which calculates the maximum of two numbers. Okay. So first thing is I need to define the type integer max, and then I have to say integer a, integer b, and then here I would say if a is greater than b, return a or return b. This is okay? Is this okay? What is that? In this case it is not required, because if it returns, it will return, otherwise it will go here. So here R is not required. Else, you are saying else, right? Yeah, in this case else is not really required, because okay, let me show you like why else is not required. See, in the first case a is 1, b is 2. Okay, so we are checking 1 is greater than 2. It is not, so it does not go inside. It will just return b. So do you understand why else is not required here? Okay, let's see. So if I give this 2 and this as 1, so here a is 2, b is 1, right? So it will just return 1, it will return 2, so it won't go here because it is returning here, right? So when you say return, the function exits, it won't execute any other line in that function, so it will still print 2. Is it okay? Okay, so we do this. Now if I want to compare, if I want to compare two double digits, what do I do? So I want to compare like cout max of 3.1, 4.1. So if I want to do this, what do I do? Will it work? So I have to write another float one, right? like this. So in this case it's actually double, because okay. So then it works, right? So in this case you can see that the name of the function has not changed, but it still works. Yeah, good, very good. So the compiler automatically calculates that it has to use this function and not this function. So you can see that the logic has not changed here, right? The logic is same. The function, if you look at the function, the logic is same. What has only changed is the type here, right? So to avoid these kind of duplication, what C++ does is it gives us something called templates. So first let us talk about the function template. So how do we declare templates? So what I say here, instead of int, I give it some generic name t. So it could be anything. It could be float, or it could be double, or it could be integer or character, whatever. So but t is supposed to be a type. So how do I say it is a template? I just say template class t. So if I say this, it will so it will take an input as type t. A template will take input t, and then there will be a new function that the compiler will automatically create a new function for you without you having to write another function. This happens during a compile time. It does not happen during runtime. That you have to be clear. Like that means, like if I define some, so how do I call this? So for integer I will say cout max int. I am passing the type here, and I am calling 2, 3. This is how I use. So suppose I want float or double. I'll say double 2.1, 3.1. So it works in first instance it works if the type that passed was int, so the whole function worked as int. Second time double was passed and the whole thing worked as double. So this is how you define function templates. So as I said, it doesn't mean that there is only one instance of this function. As soon as you declare this one, the compiler knows that it needs a function with integer type t. So internally function will generate a function with integer type, and it sees double, so it will automatically generate double. So I can also have float. Unless you declare this one, it won't create a new function for you, because it knows that you don't need double, so it won't create a new function for you, but it will create integer first. But if you declare double, it will create another function for you. So it's a very good code reuse. Like you can avoid duplication of code, and therefore you don't have to fix. If there is an issue, you can only fix it in one place. So this is required for reusability of your code. So this is one of the designing principles that we initially talked about. Um, so is it clear? Yes, you have to mention class. Yeah, this is a little bit confusing because this has nothing to do with class, right? But it doesn't have class. But this can take any type. It need not take integer, double. It can take any class, right? For C++, everything is a class. Integer or anything is a type. Class is also a type, right? So that way you have to say class t. This is the syntax. Okay, you have to just remember this. give class T. Yes. Okay, let me start. Let me go back. So suppose there was no template. Right, this is how I define a function which takes two integers and it returns a maximum of two integers. Now suppose I want a maximum of two double. What I do is I will create another function that takes double, and then I can calculate maximum of two double numbers. So far you understood?
Yes, sir.
Yeah, so we have seen that this is a duplication of code because the logic is the same inside the code, but it's only the type that is changing. So instead of creating another function yourself, what you can do is you can tell C++ that make a generic type T. Don't hard code it to any type, just make it as a generic type and make it as a template. This is how I make it a template. I say template class T. So it will automatically generate you functions as and when you require. So in this case I want integers, so this is how I pass the type here to a template function. So when you pass a type, it will generate a class with integer. So if I type double, it will pass it will create a class with double type. So it will automatically generate functions for you. You don't have to duplicate the code.
Yes, sir. Understood.
Okay. Okay. So yeah, so this is the template function. So function templates are special functions that can operate with generic types. In this case, the generic type was T, and this allows us to create a function template whose functionality can be adapted to more than one type or class without repeating the entire code for each type. Okay. So now let's come to template. We talked about template functions. Let's come to template classes. So suppose I want to create a class called rectangle. Okay. So sometimes rectangle has we sometimes we use integer value, sometimes we want double. So we'll make it a template. Instead of hard coding the type, we will say template and the generic type is T. So we'll create width comma height. Okay. Rectangle TA comma B, width is equal to A, height is equal to B. T, get area, return width star height. So this is how I create a template class. So everything remains same. I just say a template class T and then I replace wherever I want to use T. Like in case I want width and height to be generic type, and I want input also should be generic type, and also get area, because if t is integer, output also will be integer. If t is float, output also will be float. The area also will also be float. So I can use t here. Is it clear?
How we call this class?
Yeah. So this is how we create a rectangle, integer, r1, 2, 3. Float 2.1, 3.4. Okay, I think it is yeah. Okay. So it will convert into float basically. The 2.1 is a double, but the automatic conversion happens because double can be converted into float. So I can say cout r1 dot get area. R2 dot get area. So it works. So I can make this integer also. In that case, it will call integer 1, but the value will be get converted into integer instead of float. So that is the function class template classes. The other thing I wanted, so this template classes. So there's something called template specialization. So suppose I have I've created a generic function or class like this, but I want to kind of specialize it to character types, right? If I want to make max work for character, sometimes for characters say capital A and small a, we are giving same precedence. We don't want small a to have higher value than smaller a. So the character has a different behavior. So how I can define a different function for a character is I can just say template but can be declared for So this is called a template specialization. So there is a generic template function that takes generic type t, but I want a separate implementation for character, because for character I don't want this kind of comparison. So in this case what I will do, I will say if a is greater than or equal to a is equal to a plus equal to a minus equal to a minus a. I can do the same thing for b, or I can create a 2 upper I'm doing here is I'm converting it into uppercase, the characters to uppercase, and if then I'm doing if A is greater than B, return A, otherwise return B. Okay, so or I can say here if I want to store the originality, so I'm storing the uppercase letter and I'm converting both A and B to uppercase, and I'm comparing the uppercase, and then if the uppercase in whichever is greater in the uppercase, I'm returning that value. So we don't have to worry about the lowercase and uppercase. For example, if I say cout max of A comma B, let's see where it goes. So you can see it is coming to this particular thing, because it is automatically identified A is a character, so it is automatically coming to the character, and then in this case A is small a, it is converting into big A, B is big B, so it is remaining as B, and then in this case A is not greater than B, so it is returning B. So the output will be B, capital B. What if this was not there? If this was not there, it would print small a, which is wrong. So I'm just trying to specialize the function to a particular type. Did you get this? So this is called template space. What is that?
A is greater to B is taking in the function after a 2 upper. So it's comparing with the ASCII values, right?
Yes. You're saying here in the upper to upper or in the max?
In the max.
Yeah, in the max I'm converting both to up, because see the goal is if I give A and B, I want the answer to be B, max to be B, not small a. Okay, I don't want the ASCII value, because I mean ASCII value and all those things, these are all for computer geeks. But for person outside, if you tell somebody is A greater or B greater, he will say B is greater. He won't say small a is greater, right? He doesn't care about ASCII value. Correct? So this is for the end user. If the end user says A or
In this case, first this small a and capital B will go to the which function? It will go to first to that 2 upper, right?
yeah, it will go to upper. Let me just run through that. So it will go to upper and it's giving small a, right? So here it's coming and checking if A is greater than or equal to A. So there will be an ASCII value for A, right? ASCII value for small a is 96 or something, correct? So yeah, 97. It's here. 97 is the ASCII value of small a, and so this is less than equal to. So I want to convert it into to upper. Upper means capital A. So
Become less than equal to B equal to, right? Small a is equal to.
no, if it is greater, means it is in smaller case. Only if it is in smaller case I want to convert it into upper case. already in uppercase, I don't want to change. See, this capital A is 65, small a is 97. Yes, so if it is less than 97, if it is less than 97, I don't want to change it. So if it is less than 97, I want to keep it as it is because it is already in caps. It's already in uppercase. If it is greater than or equal to 97 only, I want to change it to uppercase because it will be in lowercase, right? So that's why I'm saying if a is greater than 97, then I'm subtracting 97 minus 65. That will be like how much? 32 or something. 32. Yeah. So 32 will a will become 65 and it will become capital A. So let's see what happens. So now a becomes 65 capital A. Right? I'm basically subtracting with 32. I don't want to hard code it, so I just put it this way. I could have as well said 32 here, like this. Or here I could have told 97 because I didn't remember what it was. I could have just told this. Yes. Okay. Yeah, you can go through the two upper later, but I want you to understand the template specialization. So like for character, I wanted to implement a different thing. So that's why I created a.
Then when it comes in our this example, small a is almost equal, so it will not subtract it. So we written directly the small a.
No, it won't write, right? Because small a will be converted into big A. So when I convert small letter a, I get big letter a, right? And b will remain same because b is already value of b is already is 66, which is less than 97. So it won't go there. It will remain capital B. It will come here. So now I am comparing 65 with 66. So which is greater? 66 is greater. So it will come here. So capital B will be written. Suppose I do the other way around. C and B, something like this. So capital A will be C, B will become capital B, and then C is greater than B, so it will return A. So this is how it will work. So this could be small c, this could be capital B. So in this case what happens? So A will be A small c, so this will be converted to capital. B is already capital, so now I see that C is still greater than B because C is 67, B is 66, so I will return A. In this case I want to return the original character, I don't want to return capital, I want to return whatever was the original, that is small c. So return C. But did you understand the template specialization? Okay, so same thing you can do for class also. Like if you want a separate implementation for some type, then you can do something. You can say template, and then you can specialize. You can explicitly specify max of this one like that. So if it was a class, you would specifically say the type here like this. Okay. Okay. So you can also specify something like a default value for this one. For this time, for this t, you can say, but the default is integer, right? If you don't specify anything, here I'm not specifying anything. So here you're saying if you don't specify anything, please do it as an integer. So that's what is default. If you give some default value here, it will do. See here. Oh. Looks like it is already doing it's creating it as double. Okay, maybe only when there is a confusion, I think it will use the default value, I think. So so you can specify default values like this, and you need not just pass in the what do you call, just the type. You can also pass in some values also, int n, like this. So let me show that with an example. I have a circle templatized, t radius, in this case I know it's always going to be double, so I'm going to make it double, because whether integer or not, when you multiply by 3.14, so I need not put t here, because whether it is integer or double, I need to return double. Okay, suppose I want a default value to be passed. C#, we don't need semicolon. Okay, so here what I have done is, if somebody creates a circle C, type integer. So if somebody creates a class called C and then says cout get area, so here you can see the radius will be set to 1 because the default value is 1. So I can set the default value of the radius here this way, or I can specify my own default value here. So just like how function has optional arguments, so we similarly have same kind of option even for templates. So very good. Yeah, so this is just for your information that you need not just pass in the type, but you can pass the you can pass a regular non-type parameter also as input to the templates, like this. Generally, I have not come across somebody using this, but yeah, sometimes you never know. Like it depends on what kind of code you're writing. Sometimes you might need to specify. So in this case, what it will do is, if I say it like this, so automatically C++ will create you two definition of classes, where one is with radius 3 and one with radius 1. So number of variations will have so many number of things defined. Clear? Yeah, so let me see what's the time. 9:42. Okay. So any questions from the previous classes? Looks like everybody got the inheritance and virtual functions and those kind of things. So I have just one more topic left. Since we have some 15 minutes, I will cover one more topic, and then in the next class we will cover exceptions, and then we will be done with the C++ training. But let me cover this one more topic for you. So I want to start with one small design pattern called singleton pattern. So in singleton pattern, what happens is people would want, say, if there is a type, a class called single. Some function, some integer. Okay. people to create multiple types of single, because if what happens is, like, if somebody creates multiple classes, there might be clash, collision, uh, and resource consumption and things like that. So sometimes we want people to use the same instance of class. Like if I say single s1, single s2, so here we have created two instances of single, right? Now if we want to restrict the user from creating more than one instance, like he should not create more than one instance, something like we have to even avoid them using it. I mean, yeah, of course, if user doesn't create, and then he can create a pointer for that one s2, and then he can keep using same instance. But in many development environment, people doesn't want uh, you know the clients creating more than one instance of this type symbol. So first of all, how do we avoid people instantiating or creating a object? Can anybody tell me, like, how do I even avoid someone creating an instance of type single outside the class? I had briefly showed you how to hide creation of the class from the client. Does anybody remember? No? Are you all there?
Yes.
Okay. So I told you, if I made the constructor private, you can never instantiate a class outside the class. Do you remember that?
Yes. If you made constructor private, keep protected also.
Yeah, protected or private, you won't be able to instantiate the class outside the class. But inside the class, you'll still be allowed to instantiate, right? So then, how do we create instance of class s1? So what I could give is I can give a static function create, and then I can say return single s. Right? So the beauty of the static classes, static functions, is that you don't need an instance to call the static function. I can just say create, and then I get the class of type s. So here I'm not allowing the user to directly, or the programmer to directly create s, but I'm asking him to go through a function called create. Okay, this is one of the patterns. And then how do I avoid that user creating multiple instances? Because here I can create multiple instances still. If I say s2, this is creating another instance. Every time I call create, it is creating a new instance of s, and it is giving me back, right? So how do I even avoid creating multiple instances? So what I can do is I can create a pointer to yes. Okay, sometimes when people say get instance, I don't want to create every time, but I want to say get instance. I want to hide the create here. And instead of the object, I'll return the pointer. I'll say if s is null, s is equal to new single. So this also has to be static, because static functions cannot access non-static classes. So I'll create one static variable s, which will point to a single class. And in get instance, what I'm doing is I'm checking if s is null, and if s is null, I'm creating a new instance of s, and then returning the pointer to that particular instance. So second time when you call instance, s is now pointing to the x is not null now, because s is now pointing to an instance. So I'll keep returning the same instance, because s is a static pointer. No matter how many times I keep calling get instance, I'll keep returning the same pointer. So this way, no matter how many get instance I do, I'll be just getting the same instance. So both s1 and s2 will be now pointing to the same address. So here you can see both s and s2 both are pointing to the same object. So just to show what happens. So first time when I call get instance, it will come here, and then s is equal to null. So I create a new object in the heap, and then I return the address for that object. So now s will be pointing to that particular object that got created in the heap. And now s2 also I call get instance. Now s is already pointing to the object in heap, so it's not null. So I just return the object to that. So when I do this, nobody can create a duplicate instance of single anywhere in the program, anywhere in the running process. So this is called a singleton pattern. So these are basically patterns are basically used to solve a particular type of issue. So just like how you say that, okay, if somebody is building a bridge, they apply standard patterns to build a bridge, like how the foundation should be, if it's a hanging bridge or is it some other bridge. So there are standard patterns they need to follow. Just like that, for solving a particular programming or coding issue, so they use particular patterns. Okay, for this problem I need singleton pattern, for this I need a factory pattern, like that. So those are called design patterns. So I won't be covering in-depth design patterns, but I want you to know that there are something like this singleton pattern, factory pattern, and those kind of things that you can probably study on your own. Since you know the basic concepts, I think you should be able to kind of study yourself on your own, and then understand those patterns. So did everybody understood the patterns, the singleton pattern? class I'll be covering exceptions. That's also an important topic. So after we are done with the exceptions, I'll be done with the C++ and OOPS. I will have to talk to Ahirji or Acharya to figure out what we're going to do next. So I'll probably give you one meaty exercise for you to go and work on. So once you complete that, I would consider you people have understood the object-oriented programming and then on C++, and then you guys are all C++ experts now. Okay, I'll probably talk and see if I can kind of give you some kind of a e-certificate, maybe signed by Acharya himself, and see that you people have completed this course once you have done with the exercise. Okay. Okay, so far, are you people comfortable with C++? Have you guys learned about linked lists? In data structures, have you learned about linked lists? Linked list, no? Okay. Okay. Yeah, there are some important things that you still need to know about in programming, like the data structures, how to implement linked lists, how to implement queue, how to implement stack. So those are all interesting topics. I'll talk and see whether they have plans for you to learn those concepts. And there's multi-threaded programming, where you can create multiple threads and then parallelly execute code. So there's multi-threaded programming also. So these two are also kind of very important topics which you will require in your tool set. So I'll talk to them, talk to Hirji first and see what are the plans of learning data structures, and see if he's going to cover it or what is the plan. So any questions, any doubts you people have? Okay. Chitrath? Nothing? Okay. Diksha? Parimala? Parimala? And forget your name, right? Yes, Parimala. Are you there, Parimala? Okay, I hope she is there and she is listening to my... Okay, fine. Okay, good. Okay, so I would like to end the class, and I will post the exercises once after the class. So we'll meet next on Monday. Hopefully that's going to be the last class for C++ and OOPS. And then